Okay, here we have a decomposition again of a rational expression where the denominator has non-repeated irreducible quadratic factor. Now the partial fraction decomposition of that rational expression where the denominator has a non-repeated irreducible quadratic factor and the degree of the numerator is less than the degree of the denominator is written as the following. So the decomposition may contain more rational expressions, and if there are linear factors. Now each linear factor will have a different constant numerator, a, b, c, and so on. So given a rational expression where the factors of the denominator are distinct, irreducible quadratic factors, decompose it. So we're going to use variables such as a, b, or c for the constant numerators over linear factors and linear expressions such as a1x plus b1, a2x plus b2, etc. for the numerators of each quadratic factor in the denominator. Then number 2, we're going to multiply both sides of the equation by the common denominator to eliminate fractions. Number 3, we're going to expand the right side of the equation and collect like terms. Number 4, we're going to set coefficients of like terms from the left side of the equation equal to those on the right side to create a system of equations to solve for the numerators. So in example number 3, we're going to find a partial fraction decomposition that contains a non-repeated irreducible quadratic factor. So this form right here, x plus 2 plus x squared plus x plus 2, cannot be factored, and that's what it means by a non-repeated irreducible quadratic factor, meaning we can't factor anymore. So in step 1, we have one linear factor and one irreducible quadratic factor in a denominator. So one numerator will be constant, meaning the a, and the other numerator will be a linear expression, bx plus c. So we're going to rewrite this now as a over x plus 3 plus bx plus c over x squared plus x plus 2. Now in step number 2, we're going to follow the same steps as in the previous problems. First, we're going to clear fractions by multiplying both sides of the equation by the least common denominator. Well, the LCD is going to be the factor denominator, so we're going to take both sides and multiply it by x plus 3 times x squared plus x plus 2. So we can eliminate the first denominator on the left side, so we're going to end up with 8x squared plus 12x minus 20. And on the right side, if we multiply the LCD by the first term, we eliminate x plus 3, so we have a times x squared plus x plus 2. And then we're going to take x squared plus x plus 2, and then we're going to simplify that with the second term. We end up getting bx plus c equals x plus 3. Now, if you notice, we could easily solve for a by choosing a value for x that will make the bx plus c term equal to 0. And that means here, since we're multiplying these two together, we can pick x to be negative 3 because negative 3 plus 3 is going to give us 0, and it's going to eliminate this entire bx plus c, and it's going to allow us to be able to solve for a. So we're going to let x equal negative 3 and substitute it into the equation. And so you can see here, wherever we have x, I substituted that to be negative 3, which is what I have in blue. So 8 times negative 3 squared is 72. 12 times negative 3 is negative 36 minus 20 equals 8 times negative 3 squared, or times negative 3 squared, which is 9, minus 3, which is 6, plus 2 gives you 8. So 8 times a is 8a. And on this side, regardless of what you get over here, negative 3 plus 3 is going to give you 0. And that 0 is going to multiply and give you 0 for that entire thing. So now we end up with the following. We have 8a plus 0, which is 8a. If we combine everything on the left side, we get 16. Divide both sides by 8, and now we have a, which is equal to 2. And now that we know the value of a, we're going to substitute it back into the equation and then expand the right side and collect like terms. So on the left side, it's going to stay the same all the way through. And then what we're going to do is we're going to plug in 2 for a. So now, substituting a to be 2, we distribute 2 to those three terms, and we get 2x squared plus 2x plus 4. And over here, bx plus c times x plus 3, we're going to FOIL that. And so we're going to end up getting bx squared plus 3bx plus cx plus 3c. And now we need to collect all the terms. So the terms that we need to collect are, here is the x squared term. So we have 2x squared and we have bx squared, and that's going to equal the value of 8. And so that's going to give us this first equation. So we have 2b plus x squared times x squared, and that gives us our first equation. Our second result is that we have 2x, we also have 3bx, and then we have cx. And that's going to equal the middle term, which is 12. So we end up getting 2 plus 3b plus cx, and that's equal to 12x. So eliminating the x, you end up getting equation 2, which is 2 plus 3b plus c. And the last one are the constants. We have 4, and then we have plus 3c, which is what we get here, and it's going to equal minus 20. And that's how we're getting the third equation. Now we can solve for b using equation 1 because b is by itself in that equation. And equation number 3 we can also solve for c since it's by itself in that equation. So solving for b in equation 1, we subtract 2 to both sides, and b is equal to 6. In equation 3, we can see that subtracting 4 to both sides and then dividing by 3, c gives us negative 8. So now we've determined that a is equal to 2, we know that b is equal to 6, and we know c is equal to negative 8. And now we can go ahead and plug in a, b, and c into our decomposition fractions. So we end up getting 2 over x plus 3 plus 6x minus 8 over x squared plus x plus 2.